Does this map look wrong to you? Why? It's a way to look at the world, right? It's just the north and south is flipped, right? That's all it's here. Well, how you all the map is a communication and a reference tool. How you make the map is really up to you. I mean, what if I turn the map 90 degrees again? Now, yeah, most often than not, the world is not displayed this way, but some people think it should because you have an innate, you're just unconscious and says if it's on top, it's more important. So, in by most people's minds, the things that happen in the northern hemisphere, and there are more people there, I fully get that, is more important than the southern hemisphere. Is the Arctic Ocean more important than the Antarctic Ocean, or also known as the Southern Ocean? That's up to you. But by the very unconscious nature of ourselves, the Arctic Ocean is more important, and also might be because for the most part we live in Minnesota. All map is a communication tool, but in the end, really, what you're looking at, one of the main things you got to look at with a map is what are you going to look at? How much of an area are you going to look at? Or is it going to be your yard, your neighborhood, your town, my country, my home, the earth? What is it? How much of the earth are you going to look at? So scale is really an important issue when looking at maps or any issue. Who does it actually affect? A small scale map shows a large area. So whenever you're looking at a map, there's going to be some sort of ratio, a fraction, a 1 meter or 1 inch equals the number of miles or feet or whatever the case may be. So a small scale map shows a large area, a large scale map shows a small area. Think about it this way. How big is your dog looking? The bigger your dog looks, this the larger scale map that it is. So it's a little flip there than normal. When you think about a large scale problem, you think about something that affects a lot of people. Yes, that's true. But if it's a map, a large scale map is going to show a small area. It's going to show a small area. Think about how big your dog would look. That tells you if it's a small scale map or a large scale map. Because thinking about this, if it's a map of the entire Earth, your dog looks really small. So it's a small scale area map. But if it's my yard, and that's why I'm glad this one has a dog in it, then it's a large scale map. Now, types of map. There's a bunch of different types of map. The first one's a reference map. This is where you're going, trying to get things in general. Political, physical. So like here, there's a road map and a political map that show you different types of reference maps. Or this one, which is a physical map of Ethiopia, or a locator map. I cannot remember what this is locating, but it's just giving you where things are, just specific spots in the United States. Thematic maps, which is a ton of them. You should know these four definitions: choropleth, dot, isoline, and cardiograms. Okay? Here you go. Cardiogram. This changes the scale of the country. And so instead of it like the country being this, the areas, what is represented, it's actually representing a different statistic. It's representing a different statistic. In this case, is population density. The larger the country, the more population density it has. Or choropleth map. This shows the unemployment rate in 2008. This is basically doing things by color. Or an isoline map. This is commonly used in weather, where it shows you different points. So like this is precipitation in Europe. Or a dot map, where this is a racial map, this is a racial map of Brazil. Now, there are also, so all this comes together and you're going to have different projections. So here are different projection maps. We're going to go through these. The most common is the Mercator, but also it has some of the biggest issues because no matter what you do, no matter what map you ever have, you're taking a 3D globe and you are putting it on a 2D surface. Therefore, no matter what, you are going to have distortion. You're going to have distortion. So that distortion, you have to have something wrong, whether that's the size, whether that's the shape, whether that's direction. You're going to have something wrong because you're going straight east the whole time while you're going at 90 degrees. Well, you're actually kind of turning a little bit with the Earth, right? And so what you have is something's going to be wrong. So really, what purpose are you using it for? This is by far the most famous map. This is the Mercator map. Look at Greenland. It is huge. It is massive. Greenland's not even close to that big. Here's the actual size of Greenland. In other words, the further you are away from the equator, the more distorted it is. What this does is you look at the lines of latitude and longitude on a Mercator map, they're perfectly straight. In other words, this is great for shipping across the ocean. It's great for direction. It is awful about everything else. Okay, look at Greenland compared to Africa here. Greenland looks bigger than Africa when Greenland is more than 10 times smaller than Africa. Okay. Okay, how about the next map here? This is the Peters projection. Straight lines still, but now things are distorted as well. Things are distorted. The shapes aren't accurate, especially around the poles. Next, we go conic. Now, the conic ones are interesting because they do have a lot of things right about them. There's no giant holes in the planet. Okay. Or this is a polar projection, so it's a different projection. Now, some of the most accepted maps in today's world, this is the Gunn-Thomas line, which is very well accepted because it does a lot of things right for land. If you're in the water, it's obviously awful because there's no gaps here. But the land is pretty good with a lot of things. But it does get a little awkward with like Greenland on two sides there. This is the most common used map today. This is the Robinson projection. It's useful for showing things across the ocean. What it does is it takes all of those factors that can be, so it's direction, its size, its proximity, and shape, and just distorts all of them a little bit. And so this is about as close as you're going to get to having a map of the world that is the most accurate. Is it perfect? No, but it's about as close as you're going to get. Things you should know from this lecture. You should know these types of map projections, and then you should also know these four types of thematic maps, and you should know a lot about scale.